When dealing with an epidemic, we can make three basic assumptions. So, one, that all individuals fit into a category, and we have the three categories. So, susceptible individuals, so that just means that they are currently healthy, but they're able to get sick. Infectious individuals, who were susceptible to the disease, but they got sick, and they are able to spread the disease. And the recovered individuals, which just means that they are no longer infectious and they are no longer susceptible to the disease either. So for the second assumption, we can assume that the population is large but fixed in size and confined to a well-defined region. So for example, students on campus for a semester. Now, the third assumption that we can make is that the population is well mixed. So this just means that everyone can come into contact with the same fraction of people in each category each day. So this is just a little diagram showing that the susceptible individuals get infected and then they go into recovery. Now the variables that I made for this model is S of t, which is just the number of susceptible individuals, I of t, which is the infected individuals, and R of t, which is the recovered individuals. And N I represented as the total population of all of the individuals. Now B is the number of contacts, so the amount of times someone comes into contact with another person, no matter what group they're in. And B is the transmission coefficient, and this is just, K is the fixed fraction of the infected group probability that they will recover. So S of t over N, I of t over N, and R of t over N is just a fraction of the population. And the derivatives of S, I, and R equal the rate at which S, I, and R change. So we can assume, like, when we add up all of the categories, so S of t over N plus I of t over N plus R of t over N equals 1. So for the susceptible equation, we know that negative B, it's negative because once someone becomes infected, they leave the susceptible population times the rate of S of t times I of t. Now, for the infected equation, it is a positive B times S of t times I of t minus K times I of t. And it is a negative K times I of t because this is the recovered equation. So once a person recovers, they leave the infected equation. And the recovered equation is K times I of t. And K, again, is the fixed fraction of the infected group, so it is the probability that they will recover in any given day.